process is test, and flight test is part of the design process. We set out with a test program with an attitude that the purpose of the test program, including lab testing, was to find and fix all problems, and to concentrate our efforts not on the negative aspects of the problem, but to celebrate the discovery of the problem so that we could find them and get them fixed before the airplane flew. And we've done a marvelous job at doing just that. We have been extremely happy with the flying characteristics throughout the entire flight envelope. In flight test, we have a larger envelope than normally will be used in service. So when I talk about the full flight envelope, I mean down to stall speed and up beyond the normal operating area that the airline crews will normally see. The stall characteristics of the 777 today are very, very good. The very first set of stalls we did indicated some problems or difficulties in the roll axis. We discovered that problem early in the program, and using some of the fly-by-wire flight control capability, we fixed that problem, and today the stall characteristics of the 777 are very, very docile. Always do calculations of what we think the drag will be in the airplane via wind tunnel tests and other kinds of tests, and in this particular case it just turned out better than predicted. Well, I think the significance of the higher than predicted cruise speed, at least from the passenger standpoint, is that on a typical flight, say from Seattle to London, that will save 15 to 20 minutes of flying time. Now, that may not appear like very much on such a long flight, but when you add those in on a daily basis, that's where that adds value to what the airlines will see. That it's necessary for the pilot to always have full control capability no matter what the situation. And we happened to be very lucky one day and got some direct crosswinds of 35 knots gusting to 47. And the airplane handled very, very well. We had several pilots fly it both during the approach and during landings and during takeoffs, and found it very easy to fly, took no special techniques, and was very, very similar to all of the other airplanes that they had flown before in those kinds of conditions. It did very well. The RTO test, that stands for refused takeoff. Each and every takeoff that is done out in commercial service has what we call a takeoff safety speed, V1. And that's the maximum speed at which you can decide to stop and not complete the takeoff. The RTO test is used to verify that all of the stopping systems on the airplane work. The brakes are capable of taking the energy that is put into them on a stop from those kinds of speeds, that the anti-skid works correctly, all of those kinds of things, and verify that the stopping distances are correct. If you can prove that the brakes are better than you expect, or that the airplane for some reason stops more quickly than what you had originally predicted, that would translate into the ability for the airlines to carry a higher payload out of a given field, and that for the airlines would be an advantage. VMU stands for Velocity Minimum Unstick, and what that really means is the minimum, that is the determination of the minimum speed at which the airplane will lift off the ground, and that is typically done with the tail in contact with the ground. The takeoff speeds are now based on a certain multiple of the minimum unstick speed. The 777 handling characteristics during the VMUs was very, very good. broke the wing on the 777 to prove that our calculations were correct. The actual results were very, very close to the calculations, because that means that the structure of the airplane is designed exactly for the amount of weight that you want to carry, and it makes a very efficient airplane. So it means that the structure is built exactly correctly, and we're carrying the minimum structural weight to do the mission that the airplane was designed for. The basic 777 program is right on schedule. We're doing extremely well. We expect to finish right on target, and the scheduling so far has been right on the numbers that we expected. We got a little bit of a late start on the ETOPS testing for the Pratt & Whitney airplane. However, we've re-examined the capability of flying at a higher rate, and we are flying at a higher rate than what we originally expected. In fact, 2 days ago, we flew 20 of those flights in one day. The most significant thing about the 777 test program, from my standpoint, is the fact that we are flying nearly twice the number of test hours that we have flown on any other test program before. As an example, the 767 test program, by the time we were through with it, we flew about 1,800 flying hours before delivery. On the 777 test program, we will fly approximately 3,300 flying hours before the airplane is delivered to the customer. This gives an indication of how much effort and how much extra time we're putting in testing the airplane to assure that we give a service-ready product.